Okay, hello, hi, this is Ryan Ahmed with you. This is lesson 14 in how to program using Haskell programming language. And in this lesson I'm going to talk about list processing. Okay, so there is a concept in this lesson called folds, okay, or folding lists. Okay. Folding list means that I have to take the whole list and process it in a way that the result will always be like an atomic result. Like it should be like one list, okay? Like if you want to look at the list as one entity, or one number, okay, a normal number, or one string, or one character, okay? It should not be like a list of lists, okay? From a normal list I want to transform it to a number, okay? So let's see some examples on folding. Sum of the numbers from 1 till, you know, the till means the double dot, till 100, okay? Let's say I want to make the factorial, which is the product of the list from 1 till 10, okay? So the factorial of 10 is this one, okay? And you see all the time the list here is folded into one number, okay? Same here. Now if I want to join so many lists together, okay, so I can say which is concatenation or concatenating, okay, the list of lists, okay, 1, 2, okay, comma, 4 and 3, or 3 or 4, okay, and 5, 6, okay. Now those inner square brackets will be deleted, so you get one list. Okay, sorry, the concat, it was a typo. Okay, so you should find this list. Okay, now there is a function which is not a fold, but it's good to know, which is replicate. Okay, and if I want to repeat the number, it's a matter of repeating a number or a character or a string a number of times. So if I want to say the letter C is repeated 4 times in a string, this is C, A. If I want to repeat the number 5 number of times in a list, so I get it like this. Okay, so I'm repeating here it 4 times. Now this function is a little bit needs some concentration. You need to know it, which is folding function named fold R, and there is fold L. Now if you guessed it, R means right, L means left. Okay, now fold R and fold left. Okay, so I want to talk first about the fold R. Okay, so it takes first of all a function f, and it has to be of 2 arguments. Okay, the second argument will be the accumulation. Okay, and the last argument will be a list. For example, let's say from 1, 2, 3, 4, 5. Okay, it's intentionally written like this. No need to. I don't want to write this format of writing the list. So there is a reason. You'll see. So what this does is, this is equivalent to f of 1, okay, because f takes 2 arguments, okay, so the second argument will be applying f again on the next element in the list, okay, of 2 f of 3, then f of 4, then f of 5, and this 3. Okay, and you close down. Okay, as needed. Anyways, this is equivalent to it. This sign is not a Haskell thing. This is from me. Okay, it's off topic here. So so what happens is that I parse the list, okay, from 1 till 5 and apply it as such. Okay, so I take f and apply it to every element in this list, as you see here. Okay, and finally I apply the 3. Okay, now fold left. If I want to talk about fold f left, this one, okay, will be a different case. So it will be, let's say like this. If I want to talk about from 1 to 3, so f, the number 3, which is the accumulation, okay, and then I put number 1, okay, then 2, then 3. Okay, if I want to, I can go further like this, and this is 4, okay, and this is more f like this, and this is 5. Cool. So I'm moving from, if you look at it from the outer side, you're moving from 5, okay, till 1. This is fold L. Okay, so I can use shorthand in defining the function, but before using that shorthand, I want to talk about that we can use the plus here, the addition, okay, as a function. And if I talk about fold L, it will be 18, and if I talk about R, it will be also 18. Okay, because this means that I will have to 1 plus 2 plus 3 plus 4 plus 5 plus the 3 at the end, because plus here has to take 2 elements, okay, 2 arguments. Okay, now both sides are equivalent in the result. Okay, that's because the plus function, or maybe if you want to use the multiplication, it's an associative operator. Okay, you can switch between the x and y, like say x plus y is equal to y plus x. This is associative. Okay, so the aim from here and the goal from here is, I want to tell you that you have to take care, if f is a different function and it's not an associative, it will give you 2 different values. Okay, so if I want to use the shorthand method, I don't want to create a function or define a function earlier to using fold R or fold L. I can directly use this. So I backslash, okay, and this is the first argument. This is the second argument of the function, this tiny function. I will say that 2x times y, okay, is this function. This represents the f here. Okay. Okay, instead of using the plus, I'm using my own function, and I'm applying it to the list and number 3. Okay, so oh, sorry, there was a typo here. Okay, so this is the function. Cool. So when I use the fold L, okay, because it's a multiplication. Now let's imagine that I'm using here a plus instead. Okay, and if I use the plus here for the folder, you see a different result, okay, because this function is not associative. Now let's move on to something called scans. Now scans is what will show me at every step of drawing or like pulling out from the list an element, okay. So every time I pull 1, then 2, then 3, then 4, then 5, then so on, so on, okay. So scan will give me at every step what fold gives me, okay, or would give me if I reach this element, okay. So scan, instead of fold R, I have scan R. It's a mix between folding and the mapping, okay. Remember the map function, you take every element, okay, and just apply the calculation on that element. There's no joint calculation between all the rest of the between all elements of the list, so you can get a single value, okay. So this is scan R. So I start with 3, okay, and I end with 33, okay. If I use scan L, so you start with 3 and end up with 1 5 3, okay. It's the opposite way around. Now there's a function called filter. Now what if I, for example, wanna pull out all the even numbers from a list, okay, of numbers? So this is where filter comes. Now I must define first is even, okay, of n, which is equal, and let's say let here, which is equal to mod n on 2, okay, double equal 0, which is I'm checking whether this division would give me a remainder of 0 when I divide by 2, okay, and a Euclidean division. Cool. And the result should be what? Either true or false. So this is what is even will give me, okay. So let's say this is my list, from 1 till 10, okay, and I want to filtrate this and get only the even numbers. So this is what I do. Let filtration, this is my own variable, I called it filtration, okay. This is the function called filter. This is where the filter comes, okay, is even on list, okay. So I get this list and I apply every element of it, okay, on is even, the function is even, and filter. Cool. So filtration, if I want to type it and print it out, this is the result of it. So I have from 1 till 10, I got all even numbers between 1 and 10. Now there is another way to use a filter, but in the way and the same way of typing this shorthand, okay, I call it a shorthand, okay. Let's say I want to do this. That is even in this shorthand method. So filtration here will be n pipe character, okay. N is part of list, okay, and I put comma and I say n here, okay, which means you should apply for me is even on every member of the list, or every element of the list, okay, and append the result to where? To the resulting list, okay. So filtration again will be this, okay. Let's say again, just for as a change, this is like 20, and filtration. Okay, now, so what if I want to get only those which are bigger than 15? Okay, and they are even too. So I can do this. I add another condition, which is n greater than or equal 15. Okay, and 15 is an odd number, of course, so you won't see it. Okay, but I want all those numbers. So filtration again, and it will give me 16, 18, 20, and that's correct. Cool. Now, what I want to build a list of pairs from list of numbers, okay, and all combinations of pairs. Okay, see how quick it is. Let's all pairs equal. Now, it's a tuple. Okay, and this tuple has to be coming from x, will be the x side, the first side, the FST side, if you remember, will be a list from 1 till 4, and the second one will be the y, okay, which is coming from 5 till 8, all the numbers between 5 and 8, and I close this. Okay, now this is true, and there is no other condition, so it's true. Okay, so if I want to print just all pairs, see, and I can add the condition here if I want. Let's say x has to be greater than or equals to 3. Okay, so if I print all pairs again, I can get them, and all x's here, see, are all 3 or 4. Okay, and I skipped and I discarded those which are less than 3. Okay, so this is all about this lesson. Okay, there's nothing much I can say, and all I want from you is to click subscribe so you can follow the channel for everything that's new. Press likes, click the ads, etc., etc. Thanks for watching.